Okay, so we're going to use SOHCAHTOA again today to find side lengths of triangles. So we're going to be using that TI-30X right here, the blue calculators we've been using. The reason we're going to continue to use these is these are the same ones that you have to use in trig. So it's kind of important that you know how to use it. The calculator should already be in degree mode. If for some reason you start typing in and you notice something weird is happening, for instance, you're doing division and you're getting out a 1, or you're getting out numbers that make no sense, or you're not getting out what you should be getting out. What I want you to do is press second and then 0, see the reset. It will ask you yes or no, are you sure you want to reset? Scroll over to yes, hit enter, and reset the calculator. It will automatically default back to degree mode, and then it will undo any setting that you may have accidentally clicked or someone else may have accidentally clicked. So again, if you're having any problems with outputs, if it says radian, see where this one says radian, it should say degree DEG. If it doesn't, hit the second reset. Or if you're having any other issues with the calculator not giving you the answer it should or something like that, just automatically reset it and it will go back to the factory settings. So anything that was accidentally marked in there or anything that is happening will go back to factory setting, and you'll be in degree mode and in all the other modes that you should be in. Okay, so if we look at number 1, so we're looking at the ratio of sides that go with that angle. So if you notice, we have opposite and hypotenuse, which is sine. So sine is equal to sine of theta is equal to opposite over hypotenuse. So if I want to solve this, then I know I have sine of 64 is equal to opposite, which is x, over hypotenuse, which is 25. So if I want to solve for x, I'm going to multiply both sides by 25. And I get 25 times sine of 64 is equal to x. So in your calculator, I have it circled right here. You see sine, cosine, and tangent. Okay, so what you'll do is you'll do 25 times sine 64, close your parenthesis, and then hit enter. And you get that x is approximately equal to 22.5. Now this isn't degrees because it's the side length, so make sure that you don't put the degree marker. Okay. Number 2, so again, it's the ratio according to the angle that I'm given. So I'm given opposite over adjacent, which is tangent. Opposite over adjacent. So tangent of my angle, 47 degrees, is equal to opposite, x, over adjacent, 12. So again, I have 12 times tan of 47 is equal to x. So x is going to be approximately equal to, so we're going to do that same keystroke, or similar, I guess not exactly the same because this is tangent. You do 12 times tangent 47, close your parentheses and hit enter, and you should get, let me double check, approximately 12.9. Okay. Number 3, so my angle is here. So the first thing I need to figure out is what trig ratio I have. I have adjacent and hypotenuse, so that's cosine. Right? So cosine of 18 is equal to adjacent x over hypotenuse 34. This is the same run through as 1 and 2. I'm going to multiply by 34 on both sides, so I get 34 times cosine of 18 degrees is equal to x. And I get that x is approximately equal to 32.3. I would like to note that some trig professors require out to the 4th decimal place, but we're only going to do 10th. Make our lives a little bit easier. So number 4, again, it's based off where this angle is. I have opposite and adjacent, so that's tangent. So that means tan of 35 degrees is opposite over adjacent. So this is going to be a two-step because I need to isolate x, so I'm going to multiply by x first. So I have x times tan of 35 degrees is equal to 9. And then I need to isolate x. So I'm going to divide by tan of 35. So I get x is equal to 9 over tangent of 35 degrees. And type that in the calculator and you get x is approximately equal to 12.9. Number 5. So here's my angle. Notice I have something across from the 90 degree. So this is definitely hypotenuse. So this is opposite over hypotenuse, which is sine. So sine theta is opposite over hypotenuse. So sine of 63 is equal to opposite 27 over hypotenuse. So again, we have that kind of two-step. So x times sine of 63 is equal to 27. Solve for x. We get x is equal to 27 divided by sine of 63. So x is approximately equal to 30.3. Okay, so I want you to figure out what the ratio is. Take a second. So it's cosine. So 18 is adjacent, so it's next to the angle. It touches the angle, and this is the hypotenuse across from the 90 degree angle. So we have cosine of 30 is equal to 18 over x. Again, two-step. So x times cosine of 30 is equal to 18. So x is equal to 18 over cosine of 30. So x is approximately equal to 20.8. Okay, so we can use the inverse of sine, cosine, and tangent to find the angle measure. So when we're given the ratio, we can find the angle measure. So for sine, then, we know that theta is equal to sine inverse of x. So basically, theta is equal to sine inverse of my ratio, which is opposite over hypotenuse. So theta is equal to cosine inverse of x, swapping the x and the theta. So then to get my angle measure, I would take cosine inverse of adjacent over hypotenuse. And the same thing here with tangent. You would take inverse tangent of its ratio, which is opposite over adjacent. SOHCAHTOA. This is just a keystroke in your calculator. So here you see that sine inverse, cosine inverse, and tan inverse are located just above the sine, cosine, and tangent keys. They're in blue, which means you have to hit second to then access. Okay? So same thing. I look at my theta and I see what ratio I have. So I have opposite and adjacent. So tangent theta is equal to opposite over adjacent, which means that in order to find this, I have to take inverse tangent. So that means inverse tangent of opposite over adjacent. So I'm going to write it out first, is equal to theta. So tan inverse of 8 over 14 is equal to theta. So theta is going to be approximately equal to, so we're going to hit second tangent, and you should see that tan looks like to the -1, but it's not. We say tan inverse of 8 divided by 14, close your parentheses, and you get approximately 29.7 degrees. Inverse tangent of 8 over 14, approximately 29.7 degrees. Don't forget your degree marker. It is important. It's just like any other unit. Okay, so we have theta. So I know I have hypotenuse because it's across from the 90, and this is adjacent. So adjacent and hypotenuse. So cosine of theta is equal to adjacent over hypotenuse, which means that cosine inverse of adjacent over hypotenuse is equal to theta. So cosine inverse, adjacent is 38, hypotenuse is 40, which is going to give me that theta is approximately equal to, so we're going to do second cosine, should have that cosine to the -1, cosine inverse, 38 divided by 40, and you get that theta is approximately equal to 18.2 degrees. Okay, number 9, so we're going to look at theta. I have opposite and hypotenuse. So that's sine theta is equal to opposite over hypotenuse, which means that inverse sine theta of opposite over hypotenuse is equal to theta. So sine inverse opposite is 17 over 22 is equal to theta. So theta is approximately equal to, so again, we're going to do second sine, 17 divided by 22, and you get approximately 50.6 degrees. Now don't be lazy with your notation. It is approximately. It's a silly reason to lose points, so don't be lazy. All right, I'm going to give you a second to work number 10. You can pause the video. If you need to, take longer if I start working and you're not done. Okay, so we have the ratio of cosine, adjacent, hypotenuse, cosine inverse, adjacent over hypotenuse, and do second cosine of 11 over 48, and you get approximately 76.8 degrees. Okay, so then we have some kind of real world problems. We have angle of elevation and angle of depression. Things you might have touched on in geometry, but definitely appear on the ACT. It's about conceptualizing what these triangles look like in a real world situation. So you have to be able to read the problem and draw an appropriate diagram, because if your diagram isn't right, then you're not going to label it. It's not going to be labeled correctly, which means you're not going to work the problem correctly. So make sure that you're taking time to read the problem and match your diagram to your problem. Okay, so we have the angle of elevation. So remember, elevation is above, so you're going to elevate from a fishing boat to the top of a lighthouse is 5 degrees. So if I'm looking at elevation, then I can imagine this is my boat and this is my lighthouse, right? Okay, and my angle of elevation is 5 degrees. So my 5 degrees goes here. It's my right angle. The top of the lighthouse is 161 feet above sea level, so I have 161 here. How far is the boat from the lighthouse? So we're looking for this horizontal distance. You can call it X, you can call it Y, A, B, doesn't matter. So once we have the triangle, we look at our angle and we decide, okay, what ratio do we have? So I have opposite over adjacent, which is tangent. So tangent theta is equal to opposite over adjacent. Now you could use Pythagorean theorem in a right triangle, but I don't have enough sides. Remember, to use Pythagorean theorem, I have to have at least 2 sides for the Pythagorean theorem to work. It's one equation, so you can't have 2 unknowns. So that's how I know I'm using SOHCAHTOA versus Pythagorean theorem. So that means tangent of 5 degrees is equal to 161 over x. So again, it's kind of that 2-part. So we have x times tangent of 5 degrees is equal to 161, and divide. So x is equal to 161 divided by tangent of 5, and we get x is approximately equal to 161 divided by tangent. Don't hit inverse this time. We're not looking for an angle measure. So 161 divided by tangent of 5 is approximately equal to 1,840.2 feet. And I know it's feet because it gives me feet in the problem. Okay. So the angle of elevation from the bottom of a slide to the top of the slide is 44 degrees. So this one is a little more straightforward. There's your slide, makes a triangle, right? It's your little ladder. It's a terrible slide. It's very dangerous. Don't go up the slide. Okay, so 44 degrees. So elevation means the rise. So this is my rise from the ground, 44 degrees. The top of the slide sits 16 feet above the ground. Find the length of the slide. So this time we're not finding the distance from the end of the slide to the ladder. We want the length of the slide. So this is kind of it's a simple concept, but it makes you have to think about the real world. Well, what part is the slide? Well, the slide is the hypotenuse, right? So that's what we're looking for. So then we go back to the same thing we did in the first few problems. Here's my angle. What ratio do I have? Well, I have opposite and hypotenuse, which is sine. So that means sine of 44 degrees has to equal my opposite, which is 16, over my hypotenuse, x. So again, we have that kind of 2-part, which you may at this point be able to skip a couple steps and get there, but I'm going to show you the whole thing. So we have x is equal to 16 over sine of 44 degrees, which we'll type in the calculator. So remember, we're not doing inverse sine because we're not looking for an angle measure. We have an angle measure. So it'll be 16 divided by sine of 44, which gives you approximately 23.0 feet. Number 13, a 10-foot ramp is used to unload furniture from a truck. If the back of the truck sits 3 feet above the ground, find the measure of the angle the ramp makes to the ground. Okay, so not in physics yet, but this is just a typical how you indicate ground. Okay, so I have a truck. Don't make fun of my truck. It's a truck. It has a ramp to unload furniture from the truck. So here's my triangle. So I know this distance here is 3 feet. And it says it's a 10-foot ramp. So my ramp itself is 10 feet. And it wants me to find the angle measure that the ramp, so my ramp, makes with the ground, which is right here, theta. Okay. So we go all the way back. So we know if we're finding an angle measure, we're going to be hitting that second sine or second cosine, second tangent to get the inverse. Okay. So I need to still look at the ratio. What ratio do I have? So I have opposite over hypotenuse, which is sine. So sine theta is equal to opposite over hypotenuse. And because I'm looking for theta, I know I'm going to do sine inverse of opposite over hypotenuse is equal to theta. So I have sine inverse. Opposite is 3. Hypotenuse is 10. So again, we go to the calculator. So second sine, 3 divided by 10. So we get that theta is approximately equal to 17.5 degrees. Okay. So angle of depression. So if angle of elevation means from the horizontal we elevate up, depression is just the opposite. From the horizontal we depress down. So we go down from the horizontal. So again, labeling your diagram is paramount to you being able to solve these. Okay, so a fire is spotted from the top of a 125-foot tall tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? So I'm going to do my ground again, just lines for ground. So my tower is 125 feet. Okay, the angle of depression, so here's my horizontal. The angle of depression to the fire, so this is my angle of depression, is 19 degrees. And here is my fire. Right? Here we go. It says, how far is the fire from the base of the tower? So this here is what I'm looking for, this distance here to the fire. Okay, now there's a couple ways that you can look at this. The first is you already have this 19 degrees, right? And we can see that this is going to make a square of 2 triangles so that we know this distance is also x and this distance is also 125. So we can use the triangle that's given and realize that this distance corresponds to this distance, and we can do that. You can find the complementary angle here and find it within this triangle. It's totally up to you how you want to do it. You should get the same answer either way. I'm just going to work with the given information, which means I'm going to find this x based off the fact that I know this distance and this distance have to be the same. My horizontal distance and my vertical distance have to be the same. So here's my 19 degrees, so it's the same process. What ratio do I have? Well, I have, remembering this is my right angle, I have adjacent over an opposite, which is tangent. So I have tangent theta is equal to opposite over adjacent. So tangent of 19 degrees is equal to 125 over what I'm looking for. So x times tan of 19 is equal to 125 divided by tan of 19. And I get x is equal to 125 over tan of 19. So then, calculator, 125 divided by tan of 19. And we get that x is approximately, 125. I missed my 1. That makes better sense. 363.0 feet. And again, I know it's feet because feet was given in the tower, was the unit of measure I'm using. Okay. Number 15. An airplane is flying at an altitude of 8,900 feet over water. So we have water. Here's my beautiful airplane. And I know this distance is 8,900 feet. The pilot spots a raft floating in the water at an angle of depression. So here's my horizontal. I'm going to draw a boat because I don't really know how to draw a raft. It's not just a rectangle. At 28 degrees. So depression means from the horizontal. So this is 28 degrees. What is the horizontal distance from the airplane to the raft? So they specifically say horizontal distance, which is this distance, or this distance. It's the same distance. Okay. Had they said just the distance, they likely would have been talking about the hypotenuse. So it's important that you note that. So I'm going to do a very similar thing that we did with the other one. I'm looking for this. This is already given, and I know if this is 8,900, this is also 8,900. So I look at my angle, and I have opposite and adjacent. So that is tangent. So tangent of 28 degrees is equal to opposite over adjacent. So x times tan of 28. And then divide. So then that's equal to, this should be approximate. So again, we're not looking for an angle. So we're using regular tangent. So we get 16,738.5 feet. Okay. Okay, so this is the last one. Max is sitting in the stands at a baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. If the horizontal distance from Max to the player is 61 feet, So here is Max in the stadium, and he's above the player in the field, right? So my triangle looks like this. And it says the horizontal distance, which is this, 61 feet from here to here. And the ball travels 76 feet. So if the actual path of the ball is 76 feet, that's the hypotenuse. If he's above him, we already have the horizontal distance. He doesn't throw it straight down into the ground. What is the angle of depression? So remember that angle of depression is from the horizontal. So like this, so I'm looking for this angle here. And remember that if this is 61 feet, this is 61 feet. So then it becomes, what trig ratio do I have? So here's my theta. I have adjacent, and across from the right angle is the hypotenuse. So that's cosine is adjacent over hypotenuse. That means cosine inverse, because I'm looking for theta, of adjacent over hypotenuse is equal to theta. So cosine inverse of adjacent, which is 61 over 76, which is hypotenuse, is equal to theta. So you're going to take your calculator, second cosine, 61 divided by 76, and we get that theta is approximately equal to 36.6 degrees. Okay, so you have a quiz tomorrow, so you need to get the practice quiz from either the sub or the basket and get to work on that for tomorrow. The key is in the binder or in the basket. The sub may have already put it in the basket. So you need to practice that for your quiz tomorrow. We will have a daily grade on this tomorrow after your quiz. Okay, so get the practice quiz, work on it, check it, and then get the tomorrow after the practice quiz. After the actual quiz, you'll have a daily grade on this. Okay.